Okay, so I am having way too much fun with this section. I just can't stop. We're going to do one more part, one more segment, two problems I hope to get through, where we're both proving identities for these. So this is 9.3 part 5. And so we're wandering back to this whole idea that we were exploring at the beginning of the chapter, where we were proving identities, right? So we know this is true, we're just proving it. We're not prove or disprove, so that's good news. But how do we get started on something like this? Look at this mess. Cosine 3x equals cosine cubed x minus 3 sine squared x times cosine. Like, I've never seen anything like that before. One of our strategies fails kind of miserably right here, and that is writing in terms of sine and cosine isn't going to help us at all, because this is written in terms of sine and cosine. So I think one way you learn about these identities is just by seeing plenty of examples in different situations where different strategies are applied. So let's get to work on this one. I'm going to start on one side of this identity and try to get to the other side. I'm going to start with cosine 3x. And so here's a strategy that, you might say, we don't have any triple angle identity on our sheet. We have double angle identities. We have sum identities and difference identities. Like, how can we get this to look like something we have an identity for? And here's what you could do. You could write that 3x as 2x plus x. And so that allows me to use the cosine of the alpha plus beta, cosine of the sum identity, which is cosine of the first, cosine of the second, minus sine of the first, sine of the second. And of course, you can refer to that on your notes or an identity sheet, so you don't have to have that memorized, but we do have to be able to use it, okay, at this point. So now I'm applying that where alpha is 2x and beta is x. So what does that come out looking like for this situation? Cosine alpha is cosine 2x. Cosine beta is just cosine x, and we're multiplying there, minus sine alpha is sine of 2x, times sine of beta is sine of x. And I would almost be ready to give up at this point, because I would be like, what? This doesn't look at all like where I want to go. But now we're going to take another step. I notice I do have a cosine 2x and a sine 2x here. We know sine 2x is 2 sine x cosine x, the double angle identity for sine. Cosine 2x, now we got a choice. So here's where, in this kind of a problem, you got to decide which form you're going to go with. If I'm never certain, I go with cosine squared minus sine squared. I'm going to try that. So what I'm going to do now is I'm going to take what I have. In the cosine 2x, I'm going to replace with the right-hand side of the cosine 2x identity. So I'm going to replace that with cosine squared x minus sine squared x. That's equal to it. And I still have times cosine x there. Minus, I've just gotten to my minus sign now. Sine 2x, I'm going to replace with the right-hand side here, 2 sine x cosine x times sine x on the end. Okay, now, what did this do for me? It still doesn't look like it's going anywhere. Well, I know I can distribute through that first parentheses. I'm going to get, now this finally, I like seeing that. Cosine squared times cosine gives me cosine to the third. I'm trying to get that cosine to the third. Good news. Minus sine squared x cosine x. Okay, well, that's not so bad either, because I want to get this coefficient of 3 there, minus 3. I only have a minus right here, but I'm starting to feel a little bit better. I don't distribute on the right, but I just multiply all that out. That's just a multiplication problem. I have minus 2 sine times sine is sine squared x cosine x. And that kind of looks like the term I want, but it's got a minus 2 instead of a minus 3 coefficient. I don't know, do you see it? We're almost there. Do you see where this is going? All we got to do is observe these are like terms. And so they can be combined. We got a coefficient of -1 here and a coefficient of -2 there. They're both sine squared cosine x terms. So I got my cosine cubed x out in front. When I add the coefficients, I get minus 3 sine squared x cosine x. And there we did it. Done. We verified the identity because we ended up on the right-hand side. That's pretty cool. So that's kind of this neat layering of identities to get a surprise at the end. And we're going to do one more. And if my little friend here can wait a few more minutes for his dinner, I'm going to try to get through one more identity. And so a similar thing here again. Prove an identity. Now this is cotangent 2 theta equals 1/2 cotangent minus tangent. Okay, whatever. I mean, again. Now, I admit a couple things. One is I would be tempted to write it in terms of sine and cosine. That's a possible strategy to use. But what I want to do is I want to show you just a different possible way to go with some of these. I'm going to use the tangent 2 theta identity. And I know I think I told you somewhere along the way I wasn't going to require that you use this one. And I guess I won't on testing. I'm still going to go through this problem because I want you to see how you can, different ways we can make use of these identities. So I'm going to use tangent 2 theta equals 2 tan theta over 1 minus tangent squared theta. But now you're saying you don't have tangent theta, you have cotangent theta. Well, I can rewrite cotangent as, let's first write cotangent 2 theta equals, it's 1 over tangent 2 theta. Right? They're the reciprocals of each other. So this guy is going to be 1 over 2 tan theta over 1 minus tangent squared theta. One over a fraction is just the reciprocal of that fraction. I can work out the division, but I'm going to end up with 1 minus tan squared theta over 2 tan theta. Now, if you're wondering, what the heck is this? What's happening here? It doesn't look like 1/2 of a difference, but again, actually, I have 2 times tan theta in that denominator. That means this fraction could be written as 1/2 times 1 minus tan squared theta over tan theta. If you multiply this out, you end up with exactly the same thing we have in the line above. So I actually got my 1/2 that we're trying to aim for. Now my goal is to try to get a difference here. And I'm kind of feeling a little like we're getting somewhere. What I'm going to do with this right-hand side, I'm going to take this a minus b over c form, and I'm going to take it apart as a over c minus b over c. It's a difference of 2 fractions. And so I have 1/2 times 1 over tan theta minus tan squared theta over tan theta. And I got to write that in parentheses now because it's 1/2 times that difference, those two terms. And so the grouping's got to be indicated here. It's 1/2 times that group of those. And oh my God, I see it now. Can you see it? We got it. Do you see that we got this one done? Because what do we have? We have 1/2. We got our parentheses. Yay, we needed parentheses. 1 over tan theta. The reciprocal of tangent is cotangent. 1 over tangent is cotangent. Minus tan squared over tangent. I can cancel a factor of tangent above and below. And so that's going to leave me with just a factor of tangent, right? You see that. I have tangent squared is tangent times tangent over tangent. So I'm just canceling a factor of tangent above and below. I'm left with tangent, and that's our right-hand side. So we just verified this identity. Done. Verified, and we're done with the problems from 9.3, and I can go feed my kitty cat now.